This is chapter 5, the functions and the pointers. Simple functions passing values between functions. What will be the output of these program? First of all, this main, we have a printf here and this is a display. Now display is calling this main again. Display is calling main again. So main control will go here. From display the control will go to this display function. Then again the control will go back to main and this will go on and on. So these two lines will be printed indefinitely. Infinite loop will be there. It's not loop basically. They'll be printed indefinitely. Then again the same situation arises here. Main is calling itself. Main is calling itself. So it will be round and round and round. So this message will be printed indefinitely. We have I equal to 45 and we want to send this I here and then we want to check something. Whatever check is there, we see if I just say that okay, this is an operator. We'll talk about that later. Let us assume it is just greater than equal to. Just assume this. So we'll get 100 here. This will be the simply output because 45 when we have a value which we are passing, 45 is greater than or equal to 45. I'm just ignoring this because we'll talk about this operator later. 45 is actually is equal to 45, so 100 will come. Next is 45. We are sending it to multiply I into 1000 and we are trying to evaluate some value with respect to this function. But the problem here is there is a multiply function which we have called, but there is no definition of multiply. In fact, we have some check here. So there will be a problem because function multiply is not defined. We have to find out the error. We are sending 3 and 4 in this function add mult, and now we are trying to print this k and l as you see here. We are trying to find out I and jj. Everything is fine up till this line. We cannot return two values. We can only return one value in C. If you want to return more than one value, then you have to use the pointers. So the function cannot return two values or more than one value at a time. This is A. This message has been assigned to A. But this message is showing something and it is not returning anything. When it is not returning anything, you cannot assign it to A. So the error is nothing because there is no syntax error. But since we don't have any value being returned, there is no need to collect A. I am again implying that this program has no problem. The only situation here is when it is not returning anything, there is no return. Why are you assigning it to A? Next is A is 15.5, character is 6, you are passing 15.5 and C here. Now you are trying to print this A and CH. So what will be printed? Now the thing is, A and CH, they are not being given any data type here. Whenever you are defining or function definition is there, you need to give the type here. This is the situation. Now we have main. You are having two messages. So first this will be called, then again this will be called. So what will be the situation? The situation is this semicolon. Whenever we give a function definition, we don't put any semicolon. So the error is a semicolon. This main, let us see. Now the problem here is you cannot have a function definition inside a function definition in C. This is not allowed. So one function cannot be defined within another function. You have to take it out here and now you can define. Answer the following. Is this a correctly written function? This is all good. This is all good. But this semicolon, when you are defining a function, you don't put a semicolon. And in fact, this way of defining means making A an integer A, you are defining it or declaring it here. This is K and R method. K and R method. Carnegie-Ritchie method. State whether the following statements are true or false. The variable commonly used in C functions are available to all functions in a program. So the variables which are used in C functions are available to all functions in a program. This is absolutely wrong. There is a scope of every variable. If it is inside some block, it is not available outside the block. If it is inside some function, it is not available outside the function. That is why we have global variables for that. So this is false. To return the control back to the calling function, we must use the keyword return. This is also not true because even if you don't have return, you can still return the control back to the calling function. The same variable names can be used in different functions without any conflict. This is absolutely correct because when you are having different functions, that means the scope is different. When the scope is different, the variables, even if you name them similar, they don't conflict. They don't have any conflict between them. Every call function must contain a return statement. No, if you want a function just to print some value, why would you return? Why would you need some return? So this is false. A function may contain more than one return statement. Yes, absolutely right. You can have multiple return statement. but only one is going to work. Every return statement in a function may return a different value. This is absolutely true. That is why you have multiple returns to return multiple type of value. A function can still be useful even if you don't pass any arguments to it and the function doesn't return any value back. See, this is true. If it doesn't, if you don't even pass any number or parameter and you don't want any return, the function can still do a needful or help, a substantial work. So don't judge a function by the return values or the parameters being passed. Even if you don't have both of these, this still function can be useful to you. Answer the following. Write a function to calculate the factorial value of any integer entered through the keyboard. So we need to write a factorial, calculate factorial of a function of an integer using a function. So this is how we include the files. Then we give a fact. This is a function. We are going to define this function. Here we are only declaring it. Then we are taking the number from the user in num. Enter a number in num. Now we'll pass this value to this factorial and the result will be taken here and this will be printed. As you see here, this we will print. So let us concentrate to this function. So we are passing some num value. We start with factorial equal to 1. Every time from 1 to this number, factorial will be factorial into I and we will return the factorial. You know the logic of this by now. We have discussed it in stretch. Write a power function, this PAB, to calculate the value of a raised to the power b. Say some 3 to the power 2 or 2 to the power 3. This function you have to write. So let us write a program to calculate the power of a value. So what we do, we include the files. We say here we give the prototype of a function and then we accept the value x and y. This is x, this is y. Here this is x, this is y. Now we just call this function power and pass the values x and y. We are passing the values here and now we're trying to print out the values which are being returned by this power. So this is x, this is y. Now this goes from 1 to y. What we are trying to do here is p is equal to p into x. We have taken say x as 2 and y as 3. So we want to find 2 to the power 3. What is happening here is initially p is 1. So first of all it goes from 1 to y. That is it will go from 1 to 3. This is x, this is y. So it will go from 1 to 3. And this is p equal to p into x. In the first case, p is 1. So this will be 1 into, what is x? We have taken x as 2. So initially p will be 2, 1 into 2. Now 1 will be incremented to 2. Now again x, this same will be done. So p will be equal to, now p is now this one, 1 into 2. And then again we have this x. So 1 x will all, this x, p, this is p and this is x. Now this again, I will be incremented. So it will be 3. So it will again run. Now p has a value 1 into 2 into 2 and now we have to multiply x also, that is 2. So 2 will be multiplied 3, this is 2 to the power 3 and this is the return value which will be printed here. Write a general purpose function to convert any given year into Roman equivalent. These are the table showing the Roman equivalent of decimal number. See, this 1988 I can write as what? 1988 I can write as say 1000 plus 500 plus 4 into 100 plus 50 plus we have 30, so 3 into 10 you can say, plus now we have 8, 35 and then we have 8. So this will be 38. This number is exactly like this. Why have I written like this? Because I have some Roman numbers which are related to these decimal values. So this is what M, I have taken it from here. 500 is what? D. So this will be D. 4 into 100 is what? 4 times 100. So this is 100, so we'll write C 4 times, C. This is 50 we have as L, 3 into 10. So we write this 10 thrice, X. What is this 8? 8 can be written as V, this is 5 and now 8 can be written as 5 plus 3, okay. So for 5 we write V and for 3, we don't have anything for 3, so we write 1 3 times. So I. So this is how we write 1988. I hope you got the idea. Now let us take one more, 1525. 1525 can be written like this. We can write 1525 as say 1000 plus we have the second one, that is 500. Then we have 20. So let us make it as 2 into 10. Then we have 5. So 5 is there. So we write 5. This 1000 will be what? M. This will be what? D. This will be what? 2 into 10. So X. And this 5 can be written as V. See, this is our value. So we have to write a program for this. So how to convert? First of all, we'll enter the year. This year will be taken here. Let us take an example of 1525. I'll just give you a glimpse so that you understand how these things are going on. 1525. So we enter first of all, this Romanized function is there. First of all, y will be what? This year. So it will be 1525, first of all. Then k will be what? 1000. So this will be 1000. The character is m. So m will go. Since y is not 9, 1525 is 9. We'll not go inside this. Y is not 4. We don't go inside this. Then we come here. J is equal to y by k. J is equal to y by k. So j will be what? Y by k. 1525 by 1000. This gives you 1. And this loop goes from 1 to j. That is, it will go from 1 to 1. And character will be printed. So character will be printed. What is the character? This is m. So first of all, m will be printed. Then we return y minus k into j, and this will be taken in yr. Y minus k into j is what? Y is what? Our 1525. This is minus, what is k? K is 1000. What is j? J is 1 here. So into 1. So what will be into 1? What will be returned? 1525 minus 1000, 525. 525 will be returned here. 525. So now this function call is over. Now we have year as 525 because this year will use. Now again 525, 500 and d will go. So now the entries will be 525, the k will be 500, and the character, you can say alphabet, can be d, will be d. Now again, this is y is not 9, it is not 4, so we come directly here. So j will be what? 525 by 500. You again get 1 because when you divide you get 1. Again you run it for one time, so character will be d. So d will be printed here. Then next time what will be returned? Y minus k into j. So 525 minus 500 into 1. So 25. So now 25 will go. 25, 100 and c. And likewise the things will go on. Okay. I hope you got the idea. That is how you get 1525 MDXXV. We have got the MD. I hope you will be able to find out how we can get this XXV. So this is how this function goes. And this is simply, if you get 9, you write IX. Because for 9 and 4, we have these symbols IV. 1 is 1. 2 is 2, 3 is 3. The thing changes at 4. So this 4 has to be treated separately. Then we have 5. This already we have. Here we have 5. See. Then 6. We know 5 plus 1 we can write 7. This is 5, 6. 7 is VII. So we can write this also. And then we have 8 VIII. There is no problem. But when we come to 9, this is IX. So we have to separately take the case of 9, IX. That is why we have taken separately 4 and 9. Because when it comes to 10, then we already have 10. That is 4 and 9 has been taken. So when it comes to 9 or 10, this will be taken care. This will be the result. And yet we have to print IX and IV. Any year is entered through the keyboard. Write a function to determine whether the year is a leap year or not. A leap year is that year which comes every 4 years. Because the earth revolves around the sun, and this is around 365 days we take, but it is not 365. Basically it is 365.25, or if I can make more, this is 365.2422, like this. So when this 25 means 1/4 of a day. So after 4 years, this 0.25, 0.25, 0.25, 0.25, this becomes 1. So now after 4 years, the year has 366 days. So in February, you get 29 days rather than 28. So how to check for a leap year? The leap year can be checked like this. If it is divisible by 4 and a number is divisible by 4 and it is not divisible by 100, then it is a leap year. Or if a number is divisible, or a year is divisible by 100, this is 400, then it is a leap year. This is the thing which we are going to use. So we will write a function. These include we do year. Now enter the year. We'll take the year in ampersand year and we'll pass it to the function. Even if you don't pass to the function, then this also works, because we can write those content, the statement here itself. So now we get the leap year and we'll just come out. So let us concentrate on this leap year. The leap year function has simple logic. If the year which is being entered, if it is divisible by 4, that is modulo is 0, equal to 0, and this has to be true together. And the modulo of it is not divisible by 0. It should not be divisible by 4. As I said, the year should be divisible by 4 if it is 0, and if it is 0, it should not be divisible by 100. So this is modulo. It should not be 0. Or this is one condition. The other condition is the year is properly divisible by 400. So y modulo 400 equal to 0. So these are two separate conditions. If these two conditions are met, this or this, the year is leap year. Otherwise we say the year is not a leap year. A positive integer is entered through the keyboard. Write a function to obtain the prime factors of this number. The prime factors of 24 are what? 2, 2, 2, 4, 2, 2, 2, 3. 35 also 5 and 7. Let me give you an example of 20 so that we'll use it there. What we do, we start with do. We start with 2. So in the program also we'll start with 2. We divide this 24 2 12s are 24. Then we'll use 12. Next time we use 12. We divide again by 2. This is 2 6 are 12. Now again we try to divide by 2. This is 2 3 are 6. Now again we try to divide by 2, but it is not divisible by 2, right? So we have to use the next number, that is 2. After 2 it is 3. So 3 1s are 3. And we stop at 1. This is the logic. We start with 2. Every time we take the next number and we go up to and we increment this number. If it is not divisible by 2, we go to 3 and we stop at 1. So we have to obtain the prime factors of a number. This is stdio.h, conio.h. We take a number, we enter the number and we pass this number to this function which is called prime. And we just in this prime will print that number. Print all these numbers which are the prime factors of any number. So what is the logic of this? As we said, we'll start with 2. So we start I with 2 and we'll print the factors here. Every time this will be printed. So while the number is not equal to 1, as I just said, we have to go up till 1. We have to go up till 1. So we'll check here. If number is not equal to 1, then only we move forward. We divide or we take the modulo of number with I, with 2. If it is equal to 0, we just print I. That is, if it is dividing 24, we get a 12 and the remainder becomes 0, we print this 2. That is how we are printing 2. Otherwise, if it is not printing, we will go on and on because this will be true for next 2 also. 2 6 are 12, 2 3 are 6. It goes like this. Now next time it is not divisible by 0. So we have to take the next one. So we are increasing else. We have to go in else. We are incrementing it by 1. So we are incrementing 2 by 3. And now we are continuing. Because we are incrementing and we are continuing. That is, we don't want to place any value here. We don't want to continue. Because we want to go again for just to check whether we get 1 or not. And every time we have to give this number as num equal to num by I. See, this 24 is num. Next time it will be num equal to num by I. So we divide 24 by 2, we get 12. So next time we will go for 12. We will search or we will do it for 12, not for 24. Next time again we go for 6, not for 12. This is how the logic goes. Function prototypes, call by value, reference, pointers. What will be the output of the program? This program. See, we are passing 1 and we are trying to find out this circle, the area of circle. So 3.14 into 1 into 1. So you should get 3.14. You return 3.14, so it will be printed. But the question here is 3.14 will not be printed. The result will be 3.000000. Why? Because this circle has no return type. And if you don't give any return type, the C is going to take it as integer. When it is integer, this 3.14 will be truncated. That is why we use C3. That is why we get the output as 3. Next is, this is slogan. Then we pass C, we have C equal to 5 and we are trying to assign this slogan to C. And see, we have no return type here because we have a void. How can you assign some void to C? There will be an error message. There has to be some return so that you can assign it to some variable. Answer the following question. Write a function which receives a float and integer. Find the product of these two and return the product which is printed through main. So just find the product of float and integer. We'll try to write a program. This is X. We take float as Y and PROD, product. We write a function prototype. This is a product function. We are passing an integer and a float, and the return type will be float. So we ask the user to input the float value and integer value. One we will take in %f, other we will take in %d. This is the product function. This is the product function, and this will be printed on, and we just come out. But before that, we have to see this function, what it does. This is int x, this is float y. What is happening here is, we are passing x, we are passing y. So we are passing some values, which is one is integer, one is float, and we have specifically given that the return type should be float. So this is how it will be returned. Write a function which receives 5 integers and return the sum, average, and standard deviation of these numbers. We call this function from main and print the result in main. So we have to find this sum, average, and standard deviation. Sum is simply adding the number. Average is adding them and dividing by the number of the content or number of the candidate values. And this is the standard deviation. Standard deviation is simply take this value, every value, subtract it from the average, square it, and add them all. And then take a square root. This is how we'll do. So this is sum, average, double we take standard deviation. We pass this to sum, average, and STDV. Why? Because we want the change to be seen here. And we print these numbers, these values actually, and we'll print them and we come out. So we have to concentrate on this function, how it works. So we are passing, because the address are being passed, address of sum. So we have to have a pointer here. Similarly for average and similarly for the standard deviation. Now we are taking 4 values. We are asking for 5 values. So we are asking for 5 values. We are taking the 5 values in 1, 2, 3, 4, 5 and 1 to 5. We are writing them and now we are assigning them to star sum. That is, star sum is what? Sum is actually the address. So we want the value at this address. So this will be added and provided to star sum, and this star sum can be read directly and divided by 5. This will give you the average. When you want to find out the standard deviation, just take the square root. For that we took square SQRT. Then we took every value, subtracted it from the average and power it with 2. So each entry, this is power function. So this is simply n1 minus avg, star avg means value at avg square. This is what we have done, and we have added all of them, 5 of them, and taken the square root, and this is how standard deviation will be computed. What will be the output of this program? See, we are passing I and we are passing j in this junk, and then this 5 will be passed to I and 2 will be passed to j. But the copy of I and j will be passed, not the actual I and j. When the result will be there, means I is equal to I into I, it will be here it will be 25. J will have 2 into 2, that is 4. But the situation is we want to print I and j. This I and j are the copies, so this I and j, they are the local variable of this junk. They are not going to have any effect on this I and j. So 5 and 2 will be printed. So the output will be 5 and 2 only. Now again the same situation, 5 and 2, but now here we are passing the address of or the reference of 5 and 2. So now you are trying to say or pass to the program that okay, take the address of 5 and change the value which is at this address. That means I is 5 and j is 2. Now you are passing the address of I and address of j, and now you are saying take it in some variable which is the address variable, which is the pointer variable actually. So now I will take this because this is the local variable for this. So this is the local variable. I will take the address of I and j will take the address of j. So it is saying value at I, that is 5, should be multiplied by value at j, this value at j, that is 2, and multiply them. Oh sorry, this will be 5 only. This will be same. This is I and I. Okay, 5 and 5. Now save it at the address, means the value at this address. What is the value at this address? 5. We have to save 5 into 5, that is 25. Now the actual value I and this I has changed. The value at I, the address which is having 25, the value at this address will be changed. So this will be 25. Even if you print I here or I here, you'll get 25. Similar is the case with j. So you get 25 and 4. I is 4, j is 2, I's reference is being passed and j value is being passed. And now you are multiplying the value at this address because this is a pointer variable, and you are passing the value at this address and saving it at the address only. So this will be 4 into 4, that is 16. Here also you are passing 2, so 2 into 2 will be 4. But when you print this I, because the reference has been passed, this will be changed to 16. But j, since it is passed as just a value, the j value will not be represented here because you are just sending the copy of j. You are not changing anything on that address which is being pointed by j, which is this address. So you will get 6, but this remains unchanged. So this will be 16 2. A is 13.5. This is star B, star C. Let me show you like this. This is A, it has 13.5. Now we have B, this is B, okay? This is B, and this is also C. Now B is having the address of A, so B is assigned address of A. Say the address of, because it is given, say the address is 1006. It can be anything, and we are just taking example. So B will have the address of A, reference of A. So it will have 1006 here. Now you have assigned B to C, so C will also have 1006. The address of B will be something different and C will also be something different. We are talking about the values here. And now let us print address of A. Address of A will be 1006. Then B and C. B and C value will be 106, 106. Again, because we are talking about the values of B and C. Again, this will be 1006 and 1006 for this one and this one. Next is A. What is the value of A? This will be 13.5. And in fact, it will be printed as 13.50000. We have after decimal, these are the precision values. Then value at address of A. The address of A, that is this one, address of A. What is the value? 13.5. Again 13.5 will come. Now see, these are similar. These are similar because they are not in any expression right now. That is why they are similar. So this will also be printing the same stuff, 13.50000. Star B. Star B means value at B. So value at B, this B is 1006. What is the value of B? Value of which B is pointing. Or B is pointing value 13.5. Again 13.5. Value of C. Again, C has 10006. It is also pointing to the same value. That will be 13.5. So in the above case, all 1006 will be printed as the address is given. This can be anything. It can, when you run this program, it will be different. And these all will show 13.5. So this is your output. Point out the errors, if any. I is 135, A is 135. You are passing I and A, and you are returning some C. Now this C is being used inside. This is a local variable. Now you cannot declare it outside the block. This is a block. You cannot write it here. The problem is this. So the declaration of C should be made inside the braces, which is the block. P is 23, F is 24. You are passing the address of P and F, and you are sending this P and F here. This is Q, Q plus Q, and G, G plus G. Now you are trying to print the P and F, but these values are getting the address reference, and you are not taking it as a pointer, because the address cannot be stored in just a variable. It has to be a pointer variable. Address can only be stored because address of a memory is different than a variable. The address can be, in hexadecimal. It is an unsigned integer. So now this is the flaw. You have to put star here, then this program is going to work. K is 35 and Z. Z is equal to check K. You have to print the Z. So what is going on here? This M. Let us not talk about this right now. We'll talk about this. This is the bitwise operator. We'll talk about this. But before that, this M, which is the local variable of this block or this function, this M is unknown here. So compiler will give error here because this int M has to be given here. Int has to be transferred here. This is the problem. The declaration of int M should be before the opening of the braces, either here or here. Then we have 35, and this is the pointer variable. So you are passing the address of I to this function. You are taking it in this. No problem with that. Now this is returning M plus 2. See, this is going to give you the address with 2 incremented. Say the address is 2000. This will be n plus 2. So it will give you the next address after next address. Next after next means if just assume it to be 2 byte, integer to be 2 bytes. So it will be 2002 and then 2004. Because 2 incrementation means you are trying to go 2 times ahead of the address. This will be returned. So it will be 2004 if at all case we are supposing it to be 2000. What will be the output of the following program? Int I equal to 0, I plus plus. What is this? Let us see. But we'll talk about this operator later. Here the problem is we have 2 starting braces and only 1 ending braces. You need to have this is called the indentation. You need to have the matching number of braces. Otherwise there will be an error. So we have a closing brace is missing of if. Static int I plus plus. First of all, before we go ahead, let me tell you about static. Static variable is that variable which retains its value, and retains its value because it is stored somewhere in some, let me say, just give you an example. I'm just taking it symbolically. Say some register. So when you put in register and you make it static, then that value is going to retain its value. Means if this function is called once, it will be I equal to 0. Say I become 5. When this function will again be called, this will not be made 0. This will retain its value. It will be always 5. Okay. Then if this value becomes 10, then if the function is again called, it will be 10, not 5 or 0. This is how this static is used to retain the value if you are dealing with various functions and you want one value to be common to all these functions. This is why we use static. Now let us come to this program. What is happening here is you are going inside I plus plus. I is 0, so I plus plus will make 0 as 1. You are taking at, say I just ignore this because we'll talk about this operator later. I assume it to be I less than equal to 5. Now printf, this one, you are printing I because I is less than 5, 1 is less than 5. So you are printing 1. Okay, 1 will be printed. Then you are calling main again. So you are going here. Now this, as I said, I will retain its value. So I is 1 now. I plus plus means it will be 2. Since 2 is less than 5, 2 will be printed. So this goes on and on till 5. When 5 will come here, 5 will be less than equal to 5. It is okay. Now when 6 will come, again this will be run. 6 is less than equal to 5. This is false. So it will come outside in else and we will exit. So 1, 2, 3, 4, 5 will be printed. So this will be the output. A 5-digit positive integer is entered through the keyboard. Write a function to calculate the sum of digits of 5-digit number. First without using recursion, then using recursion. So first we'll write a program without recursion. We have to calculate the sum of digits of a 5-digit number first without recursion. We include the 5, we take some variable and then we enter the number. So now we pass it to some function, some n. This is our function, and then we can print this. Just print this, that sum of digit using recursion, without recursion is this. Now we'll also write a function called rsum. which is the function with recursion. Recursion means a recursive function is a function which calls itself. Then we print the same value. So these two will come similar, but here we are not using recursion. Here we are using recursion. So let us see this first function, this one. This is a very small version. We have already seen this function, but we have we wrote it in a stretch with every value, say 5 digit, 4 digit. Now we are making it generalized, and now this is going to work for each and every value. So now we pass this sum, num, we take remainder and sum. So while this number is greater than 0, we take the remainder, add the remainder to the sum, and again divide the number by 10, and again do it till we reach 0. So every time we have a remainder, we add the remainder. That means we are taking the last value, any number, the last value we are taking out every time, and we are taking the remaining values here. Again when we are going and then we are adding. Then we are 1, 2, 4, 5. So when we take modulo, we will get 4, and this division will give you 1 to 4. So 5 will be added first because the sum is 0, so 0 plus 5. Then again this loop will go on. So 1 to 4. 1 to 4 will be again divided, taking the modulo of 10. So you get 4 now, the last one. 5 will be added with 4. 12 will be returned back. Now 12 will be again divided by or modulo 10. So you get again the next one, 2. So 5 plus 4 plus 2 you will get. Then you get 1. Again, because number is greater than 0, you get 1. All this will be added and you come out. This is how you return sum, and this will be printed. This line it will be printing. The function, similar function with the recursion. We start with sum equal to 0, remainder, same stuff. But here we say when number is not equal to 0, we take the remainder of this number, that is the modulo, and then sum is equal to remainder plus. We again call the similar function with number divided by 10. Again 1, 2, 4, 5. What we are trying to do here is we are taking modulo. 5 will come, 5 will go here. Modulo always give you the last one. If this is not divisible by the number which you are dividing, and of course this is not being divisible by 10. So 1, 2, 4, 0 plus 5. 1, 2, 4, 0 is divisible by 10, but 5 is not. So 5 will be remainder. 5 will be added with this one. This is doing what? You are calling again this function, and you are passing num by 10. That is, you are passing 1 to 4. So same thing will be done again and again till the time you reach number not equal to 0. So the same thing will be done as recursion, and sum will be returned. A positive integer is entered through the keyboard. Write a program to obtain the prime factors of the number and modify the function suitably to obtain the prime factors recursively. So you have to do it recursively also. So let us see the prime factors of a number recursively. What are the prime factors? Say if I give you number, say 24. We have already done this question without recursion. So the thing is, when you divide the number by 2, so we start with 2. We always start with 2. Then we divide 24. This is 2, 12 to 24. Then we again check for 2. If it is not, we increment 2. Because this is being divisible by 2, we again divide. 2 6 are 12. 2 3 are 6. But now this is not divisible by 2. So we increment 2. We make 3. And 3 on the 3. So we stop at 1. So this is the logic. We start with 2. And increment the value, and every time we divide the value, and when we divide, the next value will be this. Once this is being divided, we don't take this value, we take 12. After this is being divided, we take 6, and we go up to 1. As 1 is reached, we stop. So we enter the number, we take the number, and we just pass this number to the function which is called as factor. And now this factor will do what? As I said, we start with 2. Why I'm doing static? Because I just don't want to change this I equal to 2. I want it to remain as 2. And whenever I'm changing the value, means if I divide by 2, it is okay. If it is the number which is coming is not divisible by 2, I have to increment it. That is why I'm incrementing it. Then I don't want to change this value when the function enters again. And because this is a recursive call, this factor will be called again and again. So this I is less than n. So say I want to find out the factor of say 56. So I have to start from 2, reach till 55, and then I have to divide this number by I, that is 2. We start with 2, and then we print I if it is divisible. And now once 56 is divided by 2, 2 2s are 4, 2 8 is 16. Now I get 28. So this n should be divided by n should be n by I. So next time I'm not going to use 56, I'm going to use 28. So this is taking it to 28. Again we go back, this we do again and again till the time 2 is dividing it. So I will divide it by 2, it will be 19. This goes on and on. And if it is not divisible by C, 19 is not divisible by 3, I increment plus this value. Then again go back. So I have to increment I every time and see whether it is divisible or not till the time I reach the climax. And this is the factor n always calling. This n, now 28 will be passed, and this factor will be again called. So now after doing all this, we get the prime factors. Write a recursive function to obtain the first 25 numbers of a Fibonacci series. In a Fibonacci series, or sequence, the sum of two successive terms gives the third term. And following are the first few terms of the Fibonacci sequence. In the Fibonacci sequence, what is happening? Let us take a 0 here. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. So every number is the sum of the previous two numbers, right? So the logic would be, we have to take previous two numbers and add. Say if this is say old and this is current. So this old and current has to be added, and let us assign it to some new. Next time when I try to find out this Fibonacci series, next value of the Fibonacci series, I have to change this curse to old, I have to change this new to current, and then I have to add this old and current and give it to new. This is how it should go on. So 25 numbers we have to print. This is stdio.h, conio.h. We first of all take old as 0 as this one, current as 1 as this one, and we take a new, because new will be the addition of old and current. So we first take this value old and current, because this has to be initialized, and the Fibo function has to be called. This has to be given the initial value 0 and 1. Then we just print the value which are coming. But we have to go inside the Fibonacci series. See, we start with 2. Because as I just said, we need at least two values to start with. Otherwise, how are we going to find the first number? First number will be 0, 1, and then the first number actual of after adding 0 and 1 will be 1. So these are the two terms. So we have to start with two terms. Now we initialize new, which will be this one. When terms are less than equal to, say, this is 20, let me make it as 20, because I want 25 terms. 2 are already here. So let me make it, this is 2. Let me subtract 2. So 23 are remaining. So let us make it 24, because this is less than, if it would have been less than equal to, I would have done it 23, because this is less than, so I make it 24. Now let me go inside. New will be old plus current. This is old, this is this old, and this is current. So old and current are added and we pass it to new. This is old, this is current, this is new. So new will be old plus current, and this new will be printed. So this number will be printed. We have already printed these two, new will be printed. Now we add the terms will be incremented. So these are three terms. Now fourth term will come, and we again call this Fibo. Why we call this Fibo? We have added the terms now. This will be the third term. Actually, it will be fourth term now. 3 has already done. This will be the fourth term, and this current new will be what? Because we have old, which has been assigned to current here, and current will be assigned to new. So this will be done what? This will be now our old one, and this will be our current one, and again this new will be done. So because this current and new is passed, and current and new is assigned to this current, old is assigned to this old is assigned to the next one, which is the current one, and the current one is assigned to new. So new will be new, this addition of these two. So new will be old and current. This will be 1 plus 1, 2, and this goes on and on. And as you reach the number of terms, which is the limit, we return. This is how it goes. So this is all about functions and pointers. Thank you so much. Take care of yourself.